Everybody, Joe Giardillo at SOPRANOPLANET.com. I make mouthpieces for soprano saxophone. Drop by the website, check it out. There's a lot of good information about mouthpieces, about horns, about issues that we find in playing soprano, all kinds of things like that. If you have any questions about anything you see there, just drop me a line. I'm happy to answer. All right, today's video, and this is an important one, is an introduction to a new topic. And this topic is basically how a saxophone works. And I'm specifically talking about sound waves, because that's what we deal with. That's what we create. We create sound waves. And sound waves, I'm going to use those terms interchangeably. They're the same thing in this video. It's a strange thing. They behave in ways that are counterintuitive to common sense sometimes. And once we start to recognize what actually is going on, then certain things that made no sense start to make sense. And certain explanations and old wives' tales that we've developed to, quote unquote, explain certain situations playing saxophone become obviously old wives' tales, okay? Because now we know a little bit more about what's actually going on. Okay, so here's what it comes down to. Look, there's a lot that's been studied about sound, and it's been going on for a long time. A good indication of that is we have medical imaging that's done with ultrasound. So we've taken sound and we've brought it inside our bodies so that we can actually do medical diagnoses, okay? Which is quite something. So there's a lot known. Here's another known thing about sound that has to do with an animal, the bat. So the bat emits very high frequency pitches, way above our hearing, in order to echolocate prey and to navigate in dark environments. Okay. We know that happens, and we know we can't hear it, but because it's so super high frequency. Well, it turns out it's a good thing we can't hear it. And the reason that is that it's been studied. And it turns out that the volume of those high frequency pitches that are used by a bat, it's about the same as a jet engine. Now think about that. This is going on all around us. We don't have any clue that that's going on. Loud as a jet engine. Okay, so that should tell you that sound is really pretty strange, okay? We would think, at least I thought, well, the bat sound is very small. No, it's not small at all. It's really loud. Okay, so look, there's the beginning of it. Now let's get down to some facts. I'm just going to give you 3 about sound in order to get us started here, okay? And then we're going to go from there in subsequent videos. So the first is that sound travels in a straight line. Sound waves travel in a straight line. They don't bend, okay? That's a fact. The second is that sound travels from its initial point of creation. The sound wave travels in all directions simultaneously. It travels every direction at the same time. Fact. And the third is that sound waves behave differently in an open environment, let's say outside, or in a closed environment, let's say in a saxophone, okay? And they behave very differently. And certain things happen that are really different and have really serious consequences in terms of sound development and the way we understand sound development as musical instrument players, okay? This is pretty amazing. Okay, so there's 3 facts. Sound travels in a straight line. Sound travels in all directions at once, simultaneously. And sound behaves differently in an open environment, such as outside, or a contained environment, such as in a musical instrument, okay? All right, so now what does that matter to us? Well, here's what matters to us, okay? Because it should bring some questions to mind. 1, okay, it travels in a straight line. What happens when here's the question, what happens when it encounters an obstacle, which it has to do? Okay, what does it do? The second thing is it travels in all directions at once. Well, the question that comes to mind is, all right, does that mean that the sound wave, when I think I'm pushing it through my saxophone, is it also coming inside me and into my oral cavity and into my air support? Okay, the answer is yes. Okay, and the third is if sound waves behave differently in an open environment or in a contained environment, what are the differences and what do they mean? Okay. Well, these are all great questions, and we're going to take a moment just to address each one of them. First, sound waves move in a straight line. What happens when they encounter an obstacle? Well, here's what happens when they encounter an obstacle. They reflect off that obstacle, number one. And number two, they penetrate that obstacle and basically cause part of that obstacle to vibrate at the frequency of the sound wave that hits it. Okay, that's one thing that happens. Okay? Now, if sound waves move in all directions at once, does sound when I'm playing my saxophone, does that return to me? Does that go inside me? I told you, yes, it does. And what does that mean? Well, most players have a good idea that the shape of their oral cavity has a lot to do with the quality of their sound, the quality of intonation, all kinds of things, okay? So we have some clue of that. Maybe some of you don't, but many of you do. All right, and then the third fact that sound in an open environment behaves different than sound waves in a contained environment. Well, what does that mean what does that actually mean? What do you mean behaves differently? Okay, and this is an important point. Here's how it behaves differently, and I'm going to use, for instance, I use the saxophone as an example. The sound can't move in all directions because it's constrained by the cone of I'm going to use the soprano, the cone of the soprano saxophone. It's contained inside there. Okay? It can move into that constrained environment and it can move back into us, but it's in this constrained environment that it exists. It doesn't get outside that environment until it reaches the end of the bell or the end of whatever tone hole is open. Okay, tone holes are open. Let's close all the fingers. Let's play the low B flat. Let's just deal with the entire length of the soprano saxophone. And so we play that B flat, and that's the fundamental resonance of that horn, that soprano saxophone. That's the fundamental resonance. That's where the instrument as a whole wants to resonate. Okay, that is it. If you made it shorter like a sopranino, then it's different. It's a different fundamental resonance. We know this, okay? And it goes on for alto and tenor and such and such. But so now we have this fundamental resonance, okay? That's what we have. And what happens inside is that the wave, because it's constrained, it reflects off the walls and reflects off the walls in all directions till it gets to the end, okay? But we also know this about a wave that is constrained, okay? It turns into another kind of wave. It turns into what's called a standing wave. And when we look at a standing wave, because it's been constrained and we've held it in this thing, it doesn't get a chance to dissipate. It stays there. And we can see this in when sound waves are studied. It's a standing wave. And then our sound, we maintain that standing wave and we use that standing wave to bring out other sound waves. Okay? Well, here's what we know about what happens with a standing wave. A standing wave creates a situation where any time sound wave, that standing wave, encounters a change, it will set a sound wave pulse back in the opposite direction, okay? What do you mean a change? Well, an obstacle, for instance. So let's get away from the soprano. Let's use the tenor. The neck, okay? So it has that hump in the neck, and sound waves travel straight. So when it encounters that, that's a change, and that sends a sound wave back in the opposite direction. And each time it has a change, or each time it encounters an obstacle, it does the same thing. Now, it encounters a lot in those bends, a lot. And it's doing this each time and sending a wave back in the other direction. It can only send them in the directions that the container allows, but it's sending it backwards, okay? Now, okay, fine. That makes for a very complex set of waves that are happening in the horn, okay? And remember, it's happening at every obstacle, every instance of an obstacle. So any reflections all the time through that whole crook, and then back down into the straight. And then when we get to the bow and into the bell. So we have the same thing happening down there. Okay? This is complex. But here's one thing that this will make you really scratch your head, okay? We understand what an obstacle can be, but I said that when the sound wave encounters a change in a contained environment, it will send a pulse of a sound wave back in the opposite direction. Okay. Well, what's the difference between an obstacle and a change? Well, an obstacle we can kind of visualize. What's a change? What does that mean? Well, here's a change, and this is, I think, kind of mind-blowing. We're playing that low B flat. Okay, all the keys are closed on the soprano. A sound wave is actually a pressure wave, and that pressure wave is higher in the saxophone than it is outside the saxophone. It's air pressure. Okay? When that wave reaches the end of the saxophone to the bell and starts to go out into the open environment, it encounters a lower air pressure. We go from a higher air pressure to a lower air pressure. That's a change. Now, you might think, well, the higher air pressure would just kind of roll over that lower air pressure. You would think that, but you'd be wrong. That's a change. And because of that change, a pulse of a sound wave is generated going back to the player. Think of how complex this is now in terms of sound waves that are operating. So listen, this is the introduction to why we need to talk more about this, because this is a very complex environment, far more complex than you think, okay? Most of you think, all right? Check in soon for part 2 of this. But there's not a lot of information about the how of this. There's a lot about the physics of it, but from a saxophone player's point of view, there's not very much information about what this means to us and what we do with it or what we don't do with it, okay? There's a lot more. Hopefully you find this interesting. I certainly do. Joe Giardulo, SopranoPlanet.com. Check out the website. Drop me a line. Be well. Keep playing.